Okay, this is video number 9 of chapter 20, and this section is entitled Demonstrating the Proper Technique for Chemical Hair Relaxers. Chemical hair relaxing is a process that rearranges the structure of curly hair into a straighter or smoother form, whereas permanent waving curls straight hair. Chemical hair relaxing straightens curly hair. Other than their objective being quite different, the permanent wave and relaxer surfaces are very similar. In fact, the chemistry of relaxers and permanent wave is exactly the same. Both surfaces change the shape of the hair by breaking disulfide bonds. The most common types of chemical hair relaxers are ammonium guanidine hydroxide and sodium hydroxide. It should be noted that thio and guanidine are usually classified as no-lye relaxers, no-lye being L-Y-E, relaxers, and sodium hydroxide is considered to be a lye-based relaxer. Curly hair. There are varying degrees and types of curly hair. Some curly hair types are extremely curly, where the hair grows in long, twisted spirals or coils. Cross sections are highly elliptical and vary in shape and thickness along their lengths. Compared to straight or wavy hair, which tends to possess fairly regular and uniform diameter along a single strand, extremely curly hair is irregular, exhibiting varying diameters along a single strand. That's interesting. The thinnest and weakest sections of the hair strands are located at the twists. These sections are also bent at an extremely sharp angle and will be stretched the most during relaxing. A chain is only as strong as its weakest link, and hair is only as strong as its weakest section. Hair breaks at its weakest point. Extremely curly hair usually breaks at the twists because the inherent weakness in that section and because of the extra physical force that is required to straighten it. Thio relaxers. Thio relaxers use the same ATG that is used in permanent waving, but at a higher concentration and a higher pH. Thio relaxers are also thicker with a higher viscosity. The measurement of the thickness or thinness of a liquid that affects how the liquid flows, making them more suitable for application as a relaxer. Thio relaxers break disulfide bonds and soften hair, just as in permanents. After enough bonds are broken, the hair is straightened into its new shape and the relaxer is rinsed from the hair. Blotting comes next, followed by a neutralizer. The chemical reactions of thio relaxers are identical to those in permanent waving. Thioneutralization is used with no thio relaxers as an oxidizing agent, usually hydrogen peroxide, just as in permanents. Let me reread that. Thioneutralization. The neutralizer used with thio relaxers is an oxidizing agent, usually hydrogen peroxide, just as in permanents. The oxidation reaction caused by the neutralizer rebuilds the disulfide bonds that were broken by the thio relaxer. Thio relaxer application. The application steps for thio relaxers are the same as those for hydroxide relaxers, although the neutralization procedure is different. Relaxers may be applied with a bowl and brush or the back of a hard rubber comb. Although all thio relaxers follow the same procedures, different application methods are used for virgin relaxers and retouch relaxers. Follow the same preparation steps as virgin hydroxide relaxers. which you can see on page 619. With the possible exception of a light shampoo before a thio-relaxer. Do not forget to perform an analysis of the client's hair and scalp. Test the hair for elasticity and porosity on several areas of the head. If the hair has poor elasticity, do not perform a relaxer service. Japanese thermal straighteners. Japanese thermal straightening, sometimes called thermal reconditioning, or TR, combines use of a thio-relaxer with flat ironing. When first introduced, they were called thermal ionic reconstructors. Each manufacturer has slightly different procedures. Generally, after the hair is shampooed and conditioned, the straightener is applied to sections distributed evenly and processed until the desired degree of curl or frizz reduction is reached. Then the hair is rinsed thoroughly for about 10 minutes, conditioned and blown dry until it is completely dry. Next, each section is flat ironed. Several passes of the flat iron are required for each section. The added heat in mechanical pressing helps to make these formulas more effective than standard thio-relaxers. The hair is then neutralized and blown dry. The service can take several hours and is not always appropriate for extremely curly hair or some color-treated hair. Thermal reconditioning is considered a specialty, and many manufacturers require certification in their particular procedure. Hydroxide relaxers. The hydroxide ion is the active ingredient in all hydroxide relaxers, which are very strong alkalis with a pH over 13. Sodium hydroxide, potassium hydroxide, lithium hydroxide, and guanidine hydroxide, Guanidine, guanidine hydroxide, are all types of hydroxide relaxers, which can swell the hair up to twice its normal diameter. Wow. Hydroxide relaxers are not compatible with thio-relaxers, permanent waving, or soft curl perms due to the difference in chemistry. Hydroxide relaxers have such a high pH that the alkalinity alone can break the disulfide bonds. The average pH of the hair is about 5, and many hydroxide relaxers have a pH over 13. Did I just say that? Since each step in the pH scale represents a 10-fold change in concentration, a pH of 13 is 100 million times more alkaline than a pH of 5. This goes back to that typo paragraph too. Hydroxide relaxers break disulfide bonds differently than in the reduction reaction of thio-relaxers. A disulfide bond consists of 2 bonded sulfur atoms. In iothionization, that's iothionization, I-A-N-T-H-I-O-N-I-Z-A-T-I-O-N. In iothionization, the process by which hydroxide relaxers permanently straighten hair, the relaxers remove a sulfur atom from a disulfide bond and convert it into a lanothionine bond. Lanothionine bonds contain only 1 sulfur atom. The disulfide bonds that are broken by hydroxide relaxers are broken permanently and can never be reformed. That is why hair that has been treated with a hydroxide relaxer is unfit for permanent waving and will not hold a curl. Types of hydroxide relaxers. Metal hydroxide relaxers are ionic compounds formed by a metal, sodium, Na, potassium, lithium, Li, which is combined with oxygen, O, and hydrogen, H. Metal hydroxide relaxers include sodium hydroxide, NaOH, potassium hydroxide, KOH, and lithium hydroxide, LiOH. Although calcium hydroxide, CaOH, is sometimes added to hydroxide relaxers, it is not used by itself to relax hair. All metal hydroxide relaxers contain only one component and are used exactly as they are packaged in the container. No mixing is necessary. The hydroxide ion is the active ingredient in all hydroxide relaxers. There is no significant difference in the performance of these metal hydroxide relaxers. Lye-based relaxers. Sodium hydroxide, NaOH, relaxers are commonly called lye relaxers. Sodium hydroxide is the oldest and one of the most common types of chemical hair relaxer. At one time, it was the most popular of hair relaxers. However, no-lye relaxers have gained considerable popularity. Sodium hydroxide is also known as lye or caustic soda and can cause hair loss and skin burns if used incorrectly. No-lye relaxers. Lithium hydroxide, LiOH, and potassium hydroxide, KOH, relaxers are often advertised as and sold as no-mix, no-lye relaxers. Although technically they are not lye, their chemistry is identical, and there is very little difference in their performance. Guanidine hydroxide relaxers are also advertised and sold as no-lye relaxers. Although technically they too are not lye, the hydroxide ion is still the active ingredient. Guanidine hydroxide relaxers contain two components that must be mixed immediately prior to use. These relaxers straighten hair completely with less scalp irritation than most other hydroxide relaxers. Most guanidine hydroxide relaxers are recommended for sensitive scalps, and they are sold over the counter for home use. Guanidine hydroxide relaxers contain two components that must be mixed immediately prior to use. These relaxers straighten hair completely with less scalp irritation than other hydroxide relaxers. Most guanidine hydroxide relaxers are recommended for sensitive scalps, and they are sold over the counter for home use. I just repeated myself. Sorry about that. Although they reduce scalp irritation, they do not reduce hair damage if used incorrectly. They swell the hair slightly more than other hydroxide relaxers and tend to be more drying on the hair, especially after repeated applications. Low pH relaxers. Sulfites and bisulfites are sometimes used as low pH hair relaxers. The most commonly used are ammonium sulfite and ammonium bisulfite. Sulfites are marketed as mild alternative relaxers and are compatible with hydroxide relaxers. They do not completely straighten extremely curly hair. Low pH relaxers are intended for use on color-treated, damaged, or fine hair. There is a table 20-2 for a summary of the types and uses of hair relaxers. Interesting, it's active ingredient, what the pH is, what's it marketed as, the advantage is and disadvantages. So there are 5 different types of relaxers listed. I'll read each of them, what their pH is, what it's marketed as, and the advantages and disadvantages. Sodium hydroxide, pH 12.5 to 13.5, It's marketed as a lye relaxer. It's very effective for extremely curly hair, but it may cause scalp irritation and damage the hair. Next is lithium hydroxide and potassium hydroxide, pH of 12.5 to 13.5. It's marketed as a no-mix, no-lye relaxer. Very effective for extremely curly hair, but it may cause scalp irritation and damage the hair. Guanidine hydroxide has a pH of 13 to 13.5. It's marketed as a no-lye relaxer. It causes less skin irritation than other hydroxide relaxers, but with repeated use may dehydrate the hair. Ammonium thioglycolate, which I think is called ATG. It has a pH of 9.6 to 10. It's marketed as a thio-relaxer or no-lye relaxer. It's compatible with soft curl permanents, but its strong, unpleasant ammonia smell with repeated use may dehydrate hair. And then lastly, ammonium sulfite, ammonium bisulfite. It has a pH of 6.5 to 8.5. Marketed as a low pH relaxer and a no-lye relaxer. It's less damaging to hair, but it does not sufficiently relax extremely curly hair. All right, now we go on to base and no base relaxers. Hydroxide relaxers are usually sold in base and no base formulas. Base cream, that's highlighted, also known as protective base cream, is an oily cream used to protect the skin and scalp during hair relaxing. Base relaxers, that's highlighted, require the application of a protective base cream to the entire scalp prior to the application of the relaxer. No base relaxers, also highlighted, do not require the application of a protective base cream. They contain a protective base cream that is designed to melt at body temperature. As the relaxer is applied, body heat causes the protective base cream to melt and settle out onto the scalp in a thin, oily, protective coating. Thin, oily, protective coating. No base relaxers are an improvement only on the protection that is provided to the skin by the oils in all hydroxide relaxers. For added protection, protective base cream should always be applied to the entire scalp, hairline, and around the ears, even with no base relaxers. Relaxer strengths. Most chemical hair relaxers are available in 3 strengths: mild, regular, and super. The difference in strength of hydroxide relaxers parallels the concentration of hydroxide. Mild strength relaxers are formulated for fine, color-treated, or damaged hair. This strength is also used for texturizing hair, leaving some curl and wave in the hair. Regular strength relaxers are intended for normal hair texture with a medium natural curl. This is the most commonly used strength and often produces a smooth, straight hair. And super strength relaxers should be used for maximum straightening on very coarse, extremely curly and resistant hair. Only select clients should use this strength. When in doubt, always strand test prior to the actual application. Strand testing will help you choose the proper strength and timing, thereby avoiding damage, breakage, or hair loss. Periodic strand testing during the actual relaxer application.